Thing, like Tesla.
Geek Thoughts Micah here. Still here. Got some experimentation going on. So a while ago, I picked up one of these guys on eBay for pretty cheap, like 10 bucks with shipping. Of course, it didn't work. Thing is, there's a big resistor inside of here, and it was cracked. We'll talk about repairing that here in just a second. But it's actually a pretty interesting circuit diagram. So right here in this part, I'll zoom in later if I need to, but it's a voltage divider between 800 megohms on the big resistor and only 2.3K across the meter itself. So that's a voltage divider of a factor of 347,826. So that's how you get 40,000 volts on the input terminals, and it measures about 115 or so millivolts across the meter itself. So I tried repairing the resistor. My initial attempts didn't work so well, so I ended up building one of these guys. This is just 800 megohm resistors in series with the connector, and got a small problem you might see here. It's kind of fuzzy. So I wanted to get all the flux off of here, because I don't know what the electrical conductive properties of flux are, but they are probably worse than the air or the resistor bodies themselves. So I want to get it all out of there. Put it in an ultrasonic cleaner with some isopropyl, and I left it in there for quite some time. Too long, in fact. Didn't realize that you could get corrosion even inside an alcohol bath. Anyway, I'm going to clean that up a bit. I'm going to put it in here. But you're probably wondering about this big stack of batteries here. Well, in order to test this meter, I needed to have a reliable voltage source. It had to be DC, because this meter only works on DC. I didn't want to take some semi-random eBay AC voltage supply that I have and try to filter it through a half-wave rectifier, get some kind of bumpy... No, I wanted pure, clean DC, and for that, nothing works as well as batteries. So here I have a stack of 75 9-volt batteries. Actually, these ones here are carbon zinc, so they're closer to about 10 volts when they're brand new. And, I got it from one of these scammy type sites where you can buy a battery for like 27 cents, but they want $5 shipping. Little did they realize that they had their site configured for combined shipping. So I ordered 50 of those for the one shipping fee, plus about 25 that I had around the house anyway. So let's take a look and see what kind of voltage we are getting on this combined stack. Now, by the way, this is extremely, extremely dangerous. This is probably around 750 volts, maybe a little bit less. And it can put out as much current as the 9-volt battery stack, as a single 9-volt battery could. So yeah, getting this across your body could easily be, I would imagine, lethal. I'm not going to find out though. Okay, 731 volts. So that's pretty good. I know you guys are all wondering how much of a spark it can make. If you're good, maybe I'll show you. All right. So let's see if we can make this meter right here wiggle by putting the 731 volts across it. Now each one of these little small divisions in here is 1,000 volts. So it'll wiggle less than one of those small divisions. But that should be enough to verify that it's working. So let's see what we can do here. Okay. Let's see if I can make this thing wiggle. Yep. There we go. So let's see how accurate the resistors are. I'm going to disconnect the power line on this thing before, because it's scaring me. Okay, so this Mega here too can put out a pretty good kick, but let's see what it says. We're going to hook it up to this one first. Okay, it's settling in. $785 megohms. These are supposed to be, I think, 1% resistors. So that seems a bit low. Could be something going on with the test equipment here too. And let's try this guy here. Now you notice, to repair it, I super glued it back together. Instead of just being 5 or 8 big chunks, this is a big spiral that goes all the way around. So the voltage differential between any 2 turns of the spiral is going to be much smaller. But I just slathered on a bunch of conductive paint over the broken parts here. So that's going to basically short out a big chunk of it. So let's get this set up. Okay. I'll let this one settle in a bit. So yeah, it's reading 680 megohms. So yeah, it's a bit short. So yeah, I could put this resistor back in. I would probably want to coat it with some Corona dope, some good insulation on that outer exposed part. And I think it would work. I wouldn't have the full range of the meter anymore, but that would work. Let's turn this off. But I think I'm still liking this one better. If I put a bunch of Corona dope all around this, in my lab bench here, I'm probably not going to be pushing it as hard as some other things would do. I'm going to be measuring basically low power stuff, battery things or things from, I'm not testing power lines or anything like that. So let me know what you guys think. And if you want to see any other experiments done with a huge stack of 9-volt batteries, let me know in the comments.